All right. So because my focus has been all about games for most of the session here, I want to wrap up with a few words about what that means. Is it all just frivolous entertainment? Or can computers and creativity create something more meaningful? My argument is actually that the creativity that we express through computers drives innovation. What we find is that CPU cores long ago surpassed what you need for any kind of home or business use for the most part. Anything you might casually want to do, like check email, browse the web, computers have been able to do that for decades. We don't need the most recent advances in technology to do that stuff. What games are doing is constantly pushing the envelope of what we can do with silicon. Creative individuals are always looking for more power to be able to express more, show more detail on the screen, richer sound, faster action. And so what we've got now are basically household supercomputers. This is innovation that's been driven by games, developing smaller, leaner, faster devices that are massively parallel. So things like the PS3 now they really are supercomputers you can have in your home. Networked together, they have phenomenal computing power, which is actually starting to feed back into practical uses. You may have heard of folding at home. This is actually, according to Guinness, the largest distributed computing project in the world. It uses PCs and PS3s all over the world. Anyone who wants to contribute a little bit of processing time can log in and do this. And what it's doing is folding proteins, simulating how these chemicals change and move within cell space in order to aid medical and bioinformatics research. There's actually one of the world's experts on bioinformatics is actually working here at this university, is going to be giving a talk this afternoon. His name is Ming Li. Have I gotten that right? And this games are actually helping to push forward development in that regard. Sorry, can I get a?
That we're looking at, we're just looking for like one player or anything. How does the online gaming, like what do you get into online?
I might come back to that in a few minutes. I'm just going to finish my slide deck and then do some Q&A. Thank you for your question. So the other areas of advancement that are being driven forward by games are real-time rendering. We can now render highly photorealistic scenes as fast as you can view them. That's being used in training applications for pilots, for doctors, surgeons working through minimally invasive surgery where they can't actually see what they're doing. They're now using computer simulations to be able to view that. Even in psychology, people are being able to overcome phobias in safe, controlled environments thanks to computer simulations. Another area of advancement is in the field of Hci, Human-Computer Interaction. We saw the Wii come out, I think it was about, is it 8 years ago now? No, 6? 5? No, the Xbox is 5 years old now, and it came out first. Anyway, so the Wii brought out gestural interactions into the main stage. We now see them in everything. They're ubiquitous in smartphones, not just for entertainment, but also for productivity applications. They're actually changing the way we interact with our computers, making them more natural, more intuitive, and less technical. You may have heard of the Microsoft Kinect. This has just been released. This thing is actually a computer vision system that will capture a scene and depth. So now the system can actually see you. And people are actually already turning this into some amazing pieces of experimental technology, using it to control autonomous robots, or even control robots from a distance by using gestures to actually use the robot's hands as your own. So there's really exciting developments happening in this field, thanks to the innovations that have been pushed forward into the mainstream by games. So to quickly summarize, I talked about how computers are the single most powerful tool for creative expression that any individual has available to them today. That any idea you have, any world you can envision, if you can break your idea down into rules, you can teach those rules to the computer and make it a reality. And that this creative engine, this process, has been driving advancements across all fields, not just entertainment, not just games, but science, technology, and the way we work with computers every day. So I'm going to wrap up by talking about what you can do. You can gather your ideas. Everyone's got a million of them. Break them down into rules. Figure out what is the real core idea of this idea. If I need to teach someone how to follow through this, what instructions do I need to give them? You can learn a language to actually be able to teach these rules, these instructions to a computer. Even a simple one will do. I mentioned earlier I'm not very literate in computer languages. I only know ActionScript. But I'm already able to express a lot of ideas through computers using even a very simple language. And just make it happen. Everyone has the ability to do this now. Every computer has the power. There's free software. You've got everything you need. So thank you very much, and I'll do a little bit of Q&A now. So we had one earlier question about networked gaming. Now, I didn't quite catch what the details of that were. How does it work? It's a can of worms. It's made very complicated because over the internet, you don't always have a guarantee of synchronicity. I send out to the server, hey, my character just did this. I just ran through this door. I don't actually know necessarily when that piece of information is going to reach the server in who knows where, and when it's going to make that way from there over to your machine so you can actually see me walk through the door. So there's actually a lot of very sophisticated, again, rules and instructions involved in making sure that even though we don't have these guarantees about when that information is going to come through or if it's going to come through, that we still manage to keep a consistent, coherent world for all players. And it's a whole area of study on its own, so I don't know how much I can explain about it right now. But I hope that that gives an answer of the flavor of the, how that works. Yep?
What's your favorite game?
So the question is, what's my favorite game? And oh, that's a tough one. Let's see. Well, I'm going to remap it to an easier question for me to answer in a short time and talk about the games I've enjoyed recently. I've recently very much enjoyed, say, The World Ends With You for the Nintendo DS. Great game with some very innovative mechanics, new rules I haven't seen tried anywhere else that made for a very interesting experience. I recently went back and played Shadow of the Colossus for PS2 again. Beautiful game. Anyone who's interested in games as artistic expression needs to play this game. It's being released on PS3 soon, so get it then. And Portal, Valve's masterpiece. Absolutely beautiful, minimal approach to showing a player through a new world, doing things they could never do in the real world, and making it so that it's clear and intuitive for everybody. So those would be my top three at the moment. I can't say that they're the best of all time. Have we got any other questions? Sorry, did I hear someone back there? Oh.
You mentioned Connect, right? How does that work? Like, when you have access, with the Connect, you don't have it. It's just like...
Yeah, with the Kinect, it's got actually two cameras. One captures the visible spectrum that we can see. The one next to it captures infrared. And what it's doing is it's beaming out a grid or a pattern of infrared dots at you that you can't see, and then picking those back up and seeing, based on how much they've been displaced, how far into depth that particular dot is sitting. And it uses some hardware right inside the device to figure out, OK, how do I match up those points of depth to those points of color to create a full 3D scene. And then there's whole other layers of analysis that go on behind that to say, now that we know what this space looks like, where are the human figures in it? Where are the faces? How are they positioned? And also, it's able to track voices. It can recognize voices and place them in a room. There's a lot of really cool input coming through this device. So that's why it's been so interesting to homebrewers.
Okay, if there's no other questions left for Doug, so let's thank Douglas for a very interesting presentation.
Thank you.